All right, guys, we're taking a look at section 5.4a today. As always, please make sure you have your identity sheet handy. These sum and difference formulas are on the back side of your identity sheet, and you probably want a calculator today. So one thing, let's just talk about this. How would you find tangent is 75 degrees? So think about this. If you drew 75 degrees on your coordinate plane, clearly we're going to be in quadrant 1, of course. Don't judge my quick drawing there. Now, what are you going to label the sides? It's not a 30, 60, 90. It's not a 45, 45, 90. So that's what these formulas are going to help us to do. We can calculate the tan of 75 degrees using one of these sum and difference identities. We could do 30 plus 45 and do the formula on our sheet and come up with the answer, because clearly I can't label the sides here. All right, so let's take a look. These, of course, are on your identity sheet. Just showing you, I put these in U and V, of course, on your identity sheet. It's A and B. Again, don't get caught up on the variables. I think about it, sine of the first angle, cos of the second. Cos of the first, sine of the second. You could use X and Y, whatever. Doesn't matter on the variables. Think about it in terms of the first angle plus the second angle. So you can see on the left side are all the sum formulas if we're going to add 30 and 45 together. Or, of course, if we were subtracting. Maybe we wanted to do the sine of 15 degrees. 45 minus 30. Then I'm going to use something on the right column here. So a lot of calculations, as you can see. For instance, if we look at sine of u minus v, you have 1, 2, 3, 4. 4 fractions, because remember, sine, cos, tan, you're comparing sides of a triangle. 4 fractions, and then you, of course, have to simplify that. Multiply, subtract, multiply. We have to go through the operations. So here we go. You can see I put the formula up here in front of us. We're doing cos of 30 plus 45. So on your formula, of course, think of this as A, B. So I'm going to first just start by rewriting this out using the formula up top. So cos of the first angle times the cos of the second angle minus sine of the first angle. Our first angle is 30. Sine of the second angle, 45. Now clearly a lot of these we're going to be using our 30, 45, and even the 60. So you might, and I'm just going to put them on this page here, I'm going to draw out our 30 angle degree, our 60, and then of course we'll do the 45. So here's our 30 degrees, of course opposite the 31. I really didn't write that messy. Come on, smartboard. Opposite the 31, opposite the 60 root 3, hypotenuse 2. I'm also going to go ahead and draw the picture. We'll reference this so we don't have to keep drawing them. I would do the same thing on your notes or your homework today. So let's draw 45. So remember the sides on the 45 are the same, 1 and 1, and the hypotenuse square root of 2. And yes, you could get the 60 degrees, of course, off your 30 degree triangle. Obviously the missing angle is 60, but I'm just going to redraw it so it's in front of us. So 60, opposite your 60 root 3, opposite the 31, hypotenuse 2. Now I'm just going to go through and evaluate these different trig functions. So I'm going to start with cos of 30. So I'm looking at the red triangle here, cosine, remember, adjacent over hypotenuse. So square root of 3, looking at the red triangle, over 2. Cos of 45, the green triangle, cosine, adjacent over hypotenuse. And of course you would rationalize that. That's going to be square root of 2 over 2. Then we have minus sine of 30. So back to the red triangle, sine, opposite hypotenuse. And then the sine of 45, the green triangle, opposite hypotenuse, so square root of 2 over 2. So here, of course, is the setup. Now I'm just going to simplify. Square root of 3 times the square root of 2, I'm going to make it square root of 6. 2 times 2. I'm going to multiply, of course, before we subtract. 1 times the square root of 2. 2 times 2. Now, you could totally leave your answer like that, or just if you check them on the answer key, since you have the common denominator, you could put it square root of 6 minus square root of 2 all over 4. I'm going to circle both. I don't care which version you put it. Same thing. Just a little fraction problem there. So a little bit more work than maybe what we're used to, but that technically, we really just found the cosine 30 plus 45, the 75 degrees. There it is, square root of 6 minus square root of 2 over 4, using our formulas. Now, nice thing on this, cos of 30 plus cos of 45. So this is different than the last problem. Notice 30 and 45 are not in parentheses. So I'm literally going to flash it back and look at the red cosine 30-degree triangle, cosine adjacent hypotenuse. That's going to be my root 3 over 2. Then I'm going to flash it back a slide. We'll look at 45, the green triangle, cos of 45, of course, root 2 over 2, adjacent hypotenuse, that's that 1 over square root of 2, root 2 over 2. Now, you could leave it like that, of course, or as always, since you have the common denominator, you could put it all over 2. Done. No like terms, nothing to simplify, not the same answer as the previous problem, not the exact same expression. So don't get caught up in that. Make sure you're looking for those parentheses. All right, let's take a look at C. Now, you're in radians, so the first thing I would do, of course, is rewrite it so you are in degrees. Pi over 4, we should just know it, 45 degrees, and then pi over 3 would be 60. So you're really calculating the sine of 105, 45 plus 60. Clearly, if I draw 105, my reference angle would be 75. We can't label the sides. We have to go through this. So first, I'm going to use the formula at the top and rewrite this. Sine of A, of course, my first angle, 45. Cos of B, second angle, 60. Plus the cos of A, first angle, sine of the second. Now, we can go back to our previous slides to get these pictures. We don't have to redraw all the triangles, of course. Let's start with sine of 45. That was our green one. So, of course, sine of 45, opposite hypotenuse. So, of course, that was our square root of 2 over 2. I'm just going to label sine and cosine. So I'm going to replace it with square root of 2 over 2. Cos of 60. So, of course, that was our blue triangle. Too far. Cos of 60. So cos, of course, adjacent over hypotenuse, so I'm going to replace that with 1/2. And like I said, you can do the same. Just draw those 3 triangles and use them for all the problems, because it's going to turn into 30s, 60s, 45s. Cos of 45, back to the triangle here. Cos of 45, we've got our square root of 2 over 2 again, adjacent hypotenuse when we rationalize. And sine of 60. So back to the blue triangle. Let's list our sine out. Sine, of course, opposite over hypotenuse. So I'm going to replace the sine with square root of 3 over 2. All right, now we just do the math and simplify. Multiply, of course, before you add. Square root of 2 times 1, 2 times 2. Square root of 2 times the square root of 3, square root of 6, 2 times 2. Again, you can leave it. I'm just going to leave it, or you could put the numerators all over 4. Totally up to you, my friends. So that is the sine of 105 degrees. Again, that is different than this expression. We are doing the sine of 45, and we're going to add to that the cos of 60. I'm just going to put them in degrees. So different. So 45, sine of 45, back to your green triangle. Sine, of course, square root of 2 over 2. Sorry for the bell ringing, of course. All right, cos of 60. Back to your blue triangle, cosine of 60 was 1/2. So I'm going to replace that with 1 over 2. Again, I can't combine them. They're not like terms. You could leave it just like that, or since we have a common denominator, you could put it all over 2. Either one. Notice it is not the same answer as the previous problem. All right, so a little fraction work, a lot of fraction work coming at you. First off, my advice is write small. So if you take a look at it, they want you to find the exact value of sine, cos, and tan. So since we have to do all 3, and you can see all the calculations, it just takes up a lot of room. So let's start, of course, with sine. So we're doing 165 degrees, but they've already split it up, and they told you they want you to use 135 and 30. So the first thing I'm going to do is just set up my formula. And I'm clearly using red to match up with sine up there. So we're going to do the sine of the first angle, cos of the second, plus cos of the first, and then sine of the second. Now, I have not drawn a 135-degree angle yet for us, so I'm going to do that over here on the side, and we'll make our triangle. I'm going to redraw the 30 degrees also, just so they're in front of us, but 30 we already did on the previous slide. Okay, so let's start with the 30. That's, of course, nice and easy. opposite the 31, opposite the 60, root 3, hypotenuse 2. And then I'm going to do the 135 in green. Now 135 is going to be, of course, in quadrant 2. We're going to make our right triangle with the x-axis. So we have to find the difference between 180 and, of course, 135. So the difference on that, 45. So we're on the 45, 45, 90. So the side's 1 square root of 2. I just put the negative, of course, on because on this left side, you're on the left of the x-axis where the negative numbers lie. Okay, let's start calculating them out. So first they want sine of 135. So that's my green triangle. Of course, I'm just going to list it over here. Right? So the sine, of course, opposite hypotenuse. We're going to rationalize that and put square root of 2 over 2. Cos of 30, so that's our red one, of course. So our cosine adjacent hypotenuse, so I'm going to replace that with square root of 3 over 2. Cos of 135, so I'm back to the green. Cosine, of course, adjacent over hypotenuse, rationalize, negative root 2 over 2. And then sine of 30, sine of the red triangle opposite hypotenuse. All right, and then we're just going to multiply them out just like we were doing before. Square root of 2, square root of 3, square root of 6, 2 times 2. Plus a negative, let's just make it minus here, make our lives easy. Square root of 2 times 1, 2 times 2. Of course, you can put it all over 4 or just leave it. So there is my answer for sine. So next, we're still going. We're going to do cosine. So first I'm going to write it out with the formula up there, cos of A. So cos of 135, cos of B, cos of 30. And then we have minus sine of the first angle, sine of the second angle. Then we're just replacing the fractions, of course. Okay, 135, that was our green triangle. Cosine, I'm looking over there, we've got our negative, square root of 2 over 2. Cos of 30, of course, cosine of 30, cos adjacent hypotenuse, we've got it listed, the red triangle. Sine of 135, that's our green triangle, sine of that, square root of 2 over 2. And then, of course, we have sine of 30, the red triangle, sine opposite hypotenuse. All right, getting to the bottom of the screen, but I'm going to sneak it in here quick, and then I'll extend it and do some tangent. So I'm going to have negative square root of 6 over 4 minus square root of 2 over 4. Again, you could put it all over 4 or just leave it. For the sake of space, I'm clearly just going to leave it. All right, let's do tangent. So I'm going to scroll it down because I think I'm going to need just a touch more room for tangent. We'll kind of set it up over here in the corner first. So I'm going to do tan. So I'm using the formula up here at the top, the green one. Tan of the first angle plus tan of the second over 1 minus tan of the first angle, which is that 135, tan of the second. Okay, let's start filling it in, see what we can do here. Probably going to have to extend this. Okay, tan of 135. So 135 was our green triangle. I'm just going to list the tangent value. Opposite adjacent, we're going to have negative 1. So let's go ahead and fill that in. And then I've got tan of 30. So our red triangle, I'm just going to list it up here. Tan of the red triangle, I'd have opposite over adjacent, which rationalizes out. We're at 3 over 3. Okay, yeah, it's still going. Tan of 135, we already figured that out, times the tan of square root of 3. So here's the setup. Now here's where it's going to get kind of bad. We have a lot of fractions, we have radicals, we have a lot of simplifying here to do. So let's get into that. Here comes the simplifying part of this. So first, of course, I'm just going to recopy the top. Negative 1 plus square, why am I putting plus 1? Plus the square root of 3 over 2. Here we go, just copying it in. Okay, denominator 1. Now, when we have minus negative 1, those two negatives will make it a plus. That's a 3. That's a very sloppy square root of 3. Square root of 3 over 3. Now, here's my advice to you. We've got fractions, we've got radicals. This is a hot mess. The first thing I would do is try to get rid of the fractions. So I'm going to try to make our lives easy and multiply everything by a 3, top and bottom. So I'm going to distribute, and I'm going to scroll this down. I'm going to extend the page here. I'm going to multiply 3 to everything. So think about it as I'm distributing the 3 through. So I'm going to do 3 times -1. When I do 3 times the square root of 3 over 3, those 3's cancel. Now distribute on the bottom, 3 times 1. And again, when I do this guy by 3's, the 3 on the top and bottom cancel. Okay, that's looking a little bit better. Now, we're still going on the simplifying. We've done the trig part of it. Good grief. You cannot have a radical in the denominator. So now we're going to multiply by the conjugate of the denominator. So this is just a giant simplification mess. The trig work was easy. I mean, the trig work was that first line. That was a piece of cake. Now it's a lot of simplifying. All right, start multiplying. Here we go. -3 times 3. -3 times negative square root of 3. Square root of 3 times 3. Square root of 3, square root of 3, square root of 9. Let's just put it as 3. Now, of course, the denominator, the middles are going to cancel. So I'm going to do 3 times 3, root 3, negative root 3. So our denominator turns out to 6. Okay, I like the 6. I'm good with 6. Okay, combine any like terms on the top. I'm going to do -9 minus 3. 3 square roots of 3 plus 3 square roots of 3, 6 square roots of 3. Hey, and we can still simplify. We're still going, people. All of those whole numbers can reduce by 6. So -12 divided by 6. 6 divided by 6 is 1. I'm not going to write the 1 clearly. You can. And 6 over 6, 1. Who needs over 1? Whew. All that work for that little tiny answer. Again, don't panic on me. The trig part was easy. That was the first setup. It was just bad because we had fractions within a fraction. We had radicals. We had a lot of simplifying to do. All right, let's do another. Get ready for it. All right, 5 pi over 12. So my first advice to you is let's convert this into degrees. So standard, boring stuff. We've done this a million times. It turns out to be 75 degrees. Now, notice they told you on the last problem to use 135 plus 30. We're going to have to get creative. I mean, we've seen it before. We can do it. I'm going to rewrite the 75. We want to use angles that we know. 30 plus 45. Okay, so let's start. We have to do all 3 again, my friends. Let's start. Let's do sine of 30 plus 45. Let's do that guy first. Okay, so I'm filling out with the formula. Sine of the first angle, cos of the second angle, cos of the first angle, sine of the second. Now, we had all the 30 and the 45s earlier, so instead of redrawing the triangles, I'm just going to back up the truck here. So let's take a look. I think I went too far. Not far enough. Okay, here we go. So sine of 30, of course, that's the first thing that I need. Let's take a look at that. So we're going to do our sine 30. Well, let's fill them out. Take a look at your red triangle. I'm going to start with that guy. So sine of 30, of course, is 1 over 2 off that triangle. Cosine of 45, that was our green triangle. That's going to be your square root of 2 over 2. Cosine of 30, of course, cosine of 30 is going to be square root of 3 over 2. And then sine of 45, square root of 2 over 2. And again, I just want to show you where I'm getting those numbers. Instead of redrawing the triangles, 1 more, maybe 2 more. I'm looking back at these triangles. 45 was the green one, 30 is the red one. So I'm just using the sides on those triangles instead of rewriting them. Again, you can rewrite them if you want though. Okay, let's do the math, of course. Multiply before you add. 1 times square root of 2, 2 times 2. Square root of 3, square root of 2, square root of 6, 2 times 2. And of course you can leave it like that or put it all over 4, doesn't matter to me. All right, next up, cosine. Now, to save you a little bit of trauma, once in a while I'm nice to you. I hope that that looks familiar to you. This is the same as example 1a. So I'm not going to redo the whole thing because we've already done it. I'm just going to copy it down. So let's go back to example 1. One more slide. Example 1a, and there it is. We did cos of 75. I had root 6 over 4 minus root 2 over 4. I'm literally just going to copy that down. That is by design to save us a little bit of work. Once in a while, I'm nice too. But of course, we do not have tangent. We are going to do tangent. Okay, so tan of the first angle, which is 30, plus tan of the second angle, 45, over 1 minus tan of the first angle. Trust me, once you get past this, I promise the next example is easier. This is the worst part, so hang in there. You're doing good. Okay, keep on going. So the setup, of course, is easy for the tan. Now we have to go back and look at our triangles because I need that tan of 30 and tan of 45. So, whoop, too far. So tan of 30, let's look at the red triangle, of course. Tan, we need our opposite over adjacent. So right away, I'm already kind of groaning a little bit because we're going to have square root of 3 over 3 for that. So let's replace the tan of 30 with square root of 3 over 3. Oh, goodness. Tan of 45. Let's go back and look at that triangle. 45 was the green one. So 45 tan opposite over adjacent. I'm super happy that's just a 1. That makes our life a little easy, I hope. So 1. Then I'm filling in the bottom. 1 minus tan of 30. That was that square root of 3 over 3. And then, of course, tan of 45 is the 1. So now we just have to go through a course and do all the fraction. I giggle a little bit. Do all the fraction simplification, etc. I better hit an extend page on this one again too. So clearly multiplying by 1 on the bottom, I'm really just ignoring that for right now. It's not worth rewriting for that because we're probably going to run out of room. Same deal. I'm going to multiply by 3 over 3 to everything to clear out any denominators. So when I do 3 times root 3 over 3, got it. 3 times 1, got it. Then same thing on the denominator. 3 times 1, 3's cancel out when we multiply there, and we have our root 3. Now, we are right back to the same situation. You cannot have a radical in the denominator. We are going to multiply by the conjugate of the denominator. I can't write the top here. 3 plus square root of 3. Got it. There we go. Whew. Okay, start foiling. Square root of 3 times 3. Square root of 3, square root of 3, square root of 9, just a 3, 3 and 3. Yes, I'll combine those. 3 square roots of 3. So we do have some like terms up there. We will get those all combined, of course. Denominator, middles cancel. So I'm just going to do the 3 and 3, root 3 and 3, square root of 9, 3. Okay, so we move up here. So on the top, I'm going to combine the 3 plus 9, 3 square roots of 3, 3 square roots of 3. Let's make it 6. And of course, our denominator, 9 minus 3, 6. Still going, because we can reduce everything by 6. 6 goes into 12 twice. 6 goes into itself once. I just didn't write the 1. 6 goes into itself once. Again, we don't need over 1. Okay, we made it. I promise you the last example, example 3, the next one, easier. All right, so I promise you these last couple of problems are easier. You got through the hard stuff. So find the exact values, write the expression as sine, cos, or tan of an angle. So pretty much we're matching it up to which formula this looks like. Does this look like sine of a sum, cos of a sum, etc.? So I see we have cos, cos minus sine, sine. So I'm going back to a page with the identities on it here. I'm going back to the very beginning. Cos, cos, and then we have minus sine, sine. Cos, cos, minus sine, sine. Bam, here it is. So we have cosine of a sum. So keep that in the back of your head, cosine of a sum. So this is the same thing as the cosine of a sum. 60 plus 20, which of course I'm going to make that 80. And we're done. We don't have to calculate or draw any pictures or do anything. They just want you to write the expression as which one of it is, sine, cos, tan. Okay. Darn bell ringing. Okay, clearly this is a tangent one. The question is it tan of a sum or tan of a difference? So look at your positives, negatives. We have minus on top, plus on the bottom. So let's go back to our identities. Minus on top, plus on the bottom. So we have tangent of a difference. So now I'm just going to subtract the 325 and 86. Okay, so I just punched that in the old calculator, 239. Told you these were easy. Gotta love it. All right, next ones. Also pretty easy. Find the exact value of the expression. So again, I would condense it like we did the last one. So I've got cos minus sine. Cos minus sine. So back to our formulas, cos minus sine. So it's that red one that's circled. We have cosine of a sum. So I'm going to do the sum. I'm going to add them up, see what it is, cosine of a sum. So I'm going to do cosine of pi over 16 plus 3 pi. Now you could put these in degrees right away. I'm going to hold up a minute and do it in radians because I see the common denominators. 1/16 plus 3/16, 4/16. 4/16, I'm going to reduce it. I'm like, oh yeah, I got that. Pi over 4 is 45 degrees. All they are asking you for is the cosine of a 45-degree triangle. Too easy. Cosine adjacent over hypotenuse and rationalize it out. And you could have gotten the 45-degree picture, of course, from that first example. I expect you to rewrite it. Okay, B, same thing. First, we're going to figure out which identity is this. We have cos plus sine. Cos plus sine. Back to the beginning. Cos plus sine. So cos plus sine. This one. We have cosine of a difference. So I'm going to do 120 minus 30. You can do that one in your calculator for that. 120 minus 30, which clearly is 90 degrees. Well, we can evaluate the cos of 90 degrees. That, of course, is one of our quadrant angles, ordered pair 0, 1. And remember, the cosine is the first coordinate. Got it. Final one. Okay, here we go. So clearly it's tangent on this one. That is the tangent of a sum formula. So I'm going to add up 25 and 110, 135. Okay, clearly I'm going to have to draw the triangle. We drew this one earlier, so you could get it from an earlier spot in your notes. 135, quadrant 2. Make our right triangle, our reference angle 45. Clearly the negative's on here because you're on the left side of the x-axis. Tangent, of course, opposite over adjacent. Whew, made it. Told you the last problems were a little bit easier. All right, good luck. I know the simplification gets a little nasty there in the middle, but don't give up. The end ones are super easy. Have a great